So let me just tell you very briefly about what we have in CS, so you know what assets you can access. Okay. Firstly, all of our first years have published apps. That's part of their course. Okay. Microsoft have given UCL, through me and others, the largest cloud computing resource for education in Europe. We have £2.8 million worth of cloud accounts. That means that each and every one of you that joins on these projects will get a cloud account, not just for storage, but for processing. I'll talk to you in a little moment about what we mean by processing. But in addition to this, we're looking at how do we align your courses with industry. How do we refresh your syllabuses? What technologies do we need to bring into your labs? What do we have in our high-performance computing clusters for analytics? And to look at sponsored competitions and awards like this one from ARM, and to have industry guest speakers come in. We want to have people come from Microsoft Research and talk at the Fleming Society. We want to have people at ARM come and deliver you, here's the latest APIs and products and services, where do you see a best fit for the latest innovations in electrical engineering? So we have 100 students. They were working on robotics last year. How many of you worked on Arduino? Very good. So our students have been programming Arduino. We have got a lot of embedded systems, embedded hardware, but we do need your help to build much more robust platforms. Okay. The first part, that is from now until January, is to directly build proof of concepts. These are demonstrators. It can be tweaky and wiry and not all contained, but essentially you're going to be looking at a research inquiry. We're going to give you a problem domain to solve, and from your own angle, you're going to look at it with regards to your electrical engineering material and how that combines with the materials that computer science students will be investigating. You're going to get a feel for the breadth of this state-of-the-art, but also looking at problem solving, going in deep to make something that didn't yet exist. I would say that if you were measuring this as a graded outcome, you should be thinking of publishing a short paper, at least a 2 to 4 pages short paper by January by working on these projects. And also, the nature in which you have your job outcome after your degree is you work in your teams for work packages. Yeah? You have these siloed environments where you get your set requirements and you work on these work packages for a set time period. It's the research R&D process by which you go through to create your final solutions. From January till April, what we're hoping that you'll be a part of will be to create products that will be deployed. So working in your team with the CS students and the management science students and the Slade School of Art students is to actually come up with finalized product that you can launch with. You'll also get to learn from the management science students about the business trajectory, the lifetime of these ideas, what kind of outreach it will have to other markets, how your discipline as scientists, as engineers, must reach the points of interest within the business domains. So the idea is to demonstrate the curriculum of deployment, that is your design decision, your design vision, your management, and your engineering prowess. So last year's students, they got the opportunity to meet the head of Microsoft Research and their team. Andrew Blake is the head of Microsoft Research Cambridge. And we had things that were quite nice. We built a 3D games console. It had 3 screens. It booted in 1.2 seconds on a super fast SSD. The total cost of the games console was £200, but it was in a very disrespectful little box. We wanted to make a beautiful games console and certify it and go through all the proper processes to make it a games console. Similarly, Renault came and sponsored this system here. It was a Pico projector that would go on the rear window shields, rear screens of the car, and it will project your location. It will project all of your information from your phone, like your playlists. It would merge everyone's playlists from whoever was sitting in the car. And it worked well. You could send text messages, you could make phone calls from your car. But at the same time, it wasn't finalized. This is all that they ended up with. We need to actually have this as a device that can fit in the car. If we put a camera in the car doors, as you drive past buildings, it should pick up the location on the GPS coordinates, map it to the shape outline of the buildings, and give you a heads-up display of here's all this information about this building to become a tourist guide. Right? We got halfway there, and this is why you are so much more important. You are the ones that are necessary to make this realizable into products. We have created a virtual machine system, so you can run simulations, you can trial stuff before you build the hardware. We also have Hadoop access, so this is the first student cluster in the UK that is of massive scale. We have, I believe, on last count, it was 10 to 12 petabytes. Yeah, on the 4th floor labs, we have between 10 to 12 petabytes of data storage, which means that if you're going to do very large-scale data collection and large-scale data analytics, as you'll see in a moment, some of the systems are going to generate huge volumes of data. To be able to crunch that data and to do these things, we need Hadoop. So let me begin by telling you about the projects. So if you want to take notes, you will hook into, I think the slide deck, we can push it out, right? The first one is from Microsoft Research, and it is a smart scarf. Imagine that the phone facilities are actually in the scarf. And as you wrap it around you, the conductive material, it lets you talk as though you're talking in natural language, natural speed, to activate, call Bob and start talking. So we can run gestures over voice recognition, and it's embedded within the scarf. Okay? We'll be looking at universities that can give us access to wearable computing. ARM will hopefully give us a platform for this. How many of you heard of a LilyPad? Arduino LilyPad. So the Arduino LilyPad is a programmable little ARM platform that we can develop wearable, like in your jacket, sensors, and retrieve data from that. Sleepstream is for the NHS Trust. So if you imagine we have motion sensors put into the bedroom mattress, and as you're sleeping, any audio sensors, if you snore, if you have motion bracelets, we have to build each one of these sensors. So if you imagine you're moving around, for patients that have sleep apnea or that have sleep disorders, to capture the data and relay that information as they sleep normally, it should be non-disruptive as best as possible. Okay? This project came from the Director of Innovation from the NHS Trust. So this is a very important project to help establish models, statistical models, and aggregate with Microsoft's data collection. Yeah? There's a system called the Lab of Things on Microsoft's research website. They focus on these simulations of capturing large amounts of sensory data. Team 3 is working on Autolite. So this is for Facebook. And the idea here is you go to a restaurant and it has a little RFID sticker on the front. You know, the Facebook front. If you touch the sticker, a device that's on you should automatically register on your phone that you've made a conducting imprint on that sticker. So your unique ID needs to somehow transfer to your phone and then push it to Facebook to say, I like this menu item. Yeah? Similarly, you're in the gym, you're doing weights of some type, and if you like that sort of thing, then it should automatically like it on your Facebook. Now, here's where the scenario gets a little bit crazy. If you can like something, that means that you have attached yourself in the tangible world to the Internet of Things. Have you all heard of the Internet of Things? This is the world in which sensors are communicating on a very wide scale, lots of data being passed around, but it enables a desk or objects around you to have an IP address, yeah, a unique signature on the Internet. Now, if I walk down a shopping aisle and I like certain cookies, just by walking up and down that aisle, I might register that's a like. I can now capture trends about you. I can capture information about you, so that on your phone you get a discount for, Maryland cookies, right? So that's the type of cookies I like. And it's this idea that these sensory bits of information, they are very basic level. There's only some information coming in and out of it, and we need to be able to find it over a radio signal to capture it. The idea on this project is to create a RESTful web service. REST is the ability over HTTP, over the web, to publish what you can get and what you can consume. Yeah, what you can get and what you can produce. So it is the ability to reveal what information you have about a device, about a sensor, about some information, and push it out to the web. If you go to weather.com, there are weather stations around the world that are pushing out RESTful feeds. They're pushing this out over HTTP, and weather.com and other web services are just simply subscribers to that information. They're getting and pushing out information from these weather stations.